How's it going, AS Math? It's Mr. Knight here, and today we're going to talk about tangents and normals. So we've been getting the slope of the tangent line through particular points. That's what we did for the last lesson with using differentiation. And that's really what a derivative is. It's just getting the slope of our tangent line through a point on any kind of curve, okay? But we're going to talk about how to get the equation of the tangent line. And then we're also going to talk about how to get the equation of a normal line, which we'll define here shortly, okay? So we want to find the equation of tangent lines and normal lines at specific points. So there's two main lines in equations of lines that we're going to get, tangents and normals. So let's talk about the tangents first, okay? So looking at this example right here, we are given a curve x squared plus 3x plus 2, and we need to find the equation of the tangent line to the curve at that particular point 2, 12. So the first thing we got to do right off the bat is take the derivative of that function. Okay, right off the bat we need to find dy dx. Now if we apply our power rule, we end up getting that our derivative is 2x plus 3. And the next thing we need to do is actually find what the slope of our tangent line is. So to do this, we have the point 2, 12. I'm going to take that x coordinate and I'm actually going to plug it into this slope function, this derivative function right here. What that's going to do is that's going to give me the slope at that point, okay? I plug 2 in, I get 2 times 2 is 4, plus 3 is 7, and so dy dx, or I guess the slope m in this case, is 7. That's the slope of my tangent line through this point right here, okay? But I want the equation of the line. So if I want an equation of a line, I got to rely on using y equals mx plus b. And that's exactly what I'm going to use. Now, I know m is my slope, so I'm going to substitute my slope in for m right there. And I'm going to go ahead, I'm going to find b. I got to find that equation right there, okay? So I'm going to plug my point 2, 12 in for x and y respectively. When I do this, I get 7 times 2 is 14. And then I substitute 12 in for y, and then I solve for my b, my y-intercept. And so my equation of my tangent line through that point is y equals 7x minus 2. Let's look at Desmos and see what that looks like. All right, we're here on Desmos, and I have that original curve, the y equals x squared plus 3x plus 2, and the point 2, 12. And we found that the equation of our tangent line, so where it's going to touch this point, was y equals 7x minus 2. We found that with the derivative. So if I put that guy up there, yeah, you can kind of see that, and this is, I don't know why they're doing blue, so it's kind of hard to see, but that tangent line is just touching through that point. So that works out, and you can see graphically that everything is all gravy. Okay? So let's talk about normal lines now and what those actually are. So what about the normal? The normal is another name for the perpendicular line. That's it, right? That's all it is. And so if I have some kind of curve, which I drew in red, the tangent line, yeah, is this line that's just going to touch it right there. The normal is just going to be the perpendicular to my tangent line. And really, we know if a line is perpendicular to another if their slopes follow a specific pattern, right? If the gradient of tangent is m, then the gradient of the normal, m2, is just given by m2 equals the negative over 1 over the m1. Essentially, it's the opposite reciprocal of whatever our slope of our tangent line is. So if we need the equation of a normal line, it's as simple as just what we did to find the equation of the tangent. But once we get our slope, we do the opposite reciprocal, and then we plug that guy in for m up here, and then solve for the b, and we get our y equals mx plus b for that guy. Okay? So let's see an example using it. It's a little bit more involved than what I just talked about, because what we're going to do for this example is we're actually going to find the coordinates of a particular point here. All right? So we have a curve. A curve has an equation, y equals this stuff, right? It's kind of messy. And the normal to that curve at the point 4, negative 4 meets the y-axis at the point P. We need to find the coordinates of P. Okay, So we're not, we're given a point that we can use. We know that the normal of the curve is at this particular point, but we also know that whatever that line is, that normal line, okay, so if I draw my curve, and okay, and then I have the normal line going through there, basically, the point of the normal, this 4 comma negative 4, we have, but we want the point, the coordinates of this point P, something that's along this normal line, and apparently it's going to cross the y-axis, apparently. So let's see kind of what that looks like and how we can work that out, okay? First thing we got to do, we should write this equation as something a little bit different, something where we can use the power rule. So again, if I want to take this guy and move it up, I have to take the negative of its exponent, so I get 16x to the negative 1. And then minus 4, and this will be x to the 1/2. X to the 1/2 is the same as the square root of x. And now we can take the power rule of that, and yes, we're going to get the derivative, okay? So we find our dy dx. I just skipped ahead and got us what the derivative of this function was right here, okay? Once I find that guy, I know at point 4 comma negative 4, I can go ahead, I can now use that x coordinate of that point and try to find the slope. Now the slope I'm going to get is actually the slope of the tangent line. So let's find that guy first, and then we'll do the opposite reciprocal and get the slope of the normal line. Okay, so I plug in 4 into my derivative function, and I end up getting negative 2 for my slope of my tangent line. Well, what's the opposite reciprocal of that? It's going to be positive 1/2. That is the slope of my normal. So that's the one I'm going to plug in to y equals mx plus b to try to solve for b and get that equation. So using y equals mx plus b, I plug 1/2 in for m. And I'm going to use this point where the normal to the curve is, this 4 comma negative 4. And I'm going to plug that x and y values in for x and y right here. And if I do that, 4 times 1/2 is 2. I have negative 4 in for y, so I find that b is equal to negative 6. Thus, my equation of my line is y equals 1/2 x minus 6. Now, it also told me P is the point where the normal meets the y-axis. Well, if it's something is going to meet the y-axis, x has to be 0. Again, yeah, just kind of looking at Desmos, what we remember. If it meets the y-axis, the x value has to be 0. Okay? So that means with that x equals 0, I'm actually going to take that guy, and I'm going to plug it in for x right here. That'll give me my y-coordinate to get my xy point for point P. Plug that in, I get y equals negative 6. So P is the point 0 comma negative 6, and it's part of that normal line that meets not only the normal at that point 4 comma negative 4 on our curve, but it also meets on our y-axis. Again, let's go to Desmos. Let's see what that looks like. So here's my original curve right here, and I'm going to find that equation of the normal line that we just found, and as you can see, it is perpendicular to the curve right there, okay? And actually, yeah, it does meet at that point 4 comma negative 4, just what we had. Now, it's also going to meet the y-axis right here at 0 comma negative 6, and that's where we found point P to be. All right? So graphically, you can see what's going on, and hopefully that gives you more faith in what we're doing with the calculus and the algebra. This is Mr. Knight signing off. Have a good day.